Kia ora everyone. No mai, hoki mai, welcome to Microsoft. How good is this? We're super excited to have everyone in the room. So for those of you who don't know me, my name's Daniel. I'm yet another Daniel at Microsoft. And we used to do this all the time, right? 2 years ago, we would have everyone in this room or in that room next door actually hosting meetups and all sorts of events. So I'm really excited, as you can probably tell, about having a developer event here at Microsoft on level 5. So thank you so much for coming in. Kia ora, ko Daniel Larsen tōku ingoa. My name is Daniel, and I work for Microsoft on the Fast Track for Azure team. So a little bit about Fast Track. We're part of Azure Engineering. So Azure Engineering are the team that build the products and services that run on Azure. We've got Will down the back there. We've got another 3 engineers also in Auckland who are part of that team, and 400 globally. So there's 400 engineers and PMs globally who are working on some of the largest and most complex deployments into Azure today. We do this every day. This is what we love doing, and we just love helping customers to get their workloads into Azure. So if you think you've got a workload, and you're a few months out, you're ready to deploy, talk to your account manager and see if they can get you into the Fast Track program. We'd really love to work with you. So today I'm going to talk about a subject that is incredibly exciting to me. New Zealand North is coming. You've heard 2 excellent speakers, Jimmy and Luke. Thank you, and also 3 days of just really excellent talks as part of the Reactor event. So a big shout out to our Reactor friends who've just been awesome in getting this to go for us. But today I really want to focus on architecture. Okay, we're going to go a little bit deeper. So can I have a show of hands? Who's an architect or an engineer or is technical, a strategist, or is working with tech? Yeah, awesome. Okay, so I want you to put your architecture hats on because we're going to go a little bit deeper today. But before we do, we're going to do a pop quiz. Okay, so you're really going to have to think about this because there's chocolate at stake. Australians have no idea what this is, right? So what is jelly tip chocolate? Okay, so this is a big deal in New Zealand, everybody. So I really want you to focus on that. I've got 3 questions. One of them was going to be a trick question, but Jimmy actually answered it. So the first question is, how many data centres are we building for New Zealand North? Chocolate, come on. Okay, so what I'm going to do is I'm going to say, who thinks 0? Who thinks New Zealand North is running on Jimmy's desktop underneath his desk? That is not correct. Who thinks 1? 1 data centre? No. Who thinks 3? Good. Who thinks more than 3? It's not bad. I would have taken that answer, except Jimmy was very explicit about how many data centres we're building, but there could be more.
It's quite long. It's a region.
I'll get to that. Thanks, David. Yep, but we're talking about data centers right now, so we are building 3, but we could be building more, right? And we can, as you know, we have multiple data centers can make up an availability zone. How many availability zones? Chocolate, come on. 1. Who says 1? 1 there, 1 there. Who says 2? Who says 3? 3 availability zones? Good. Who says more than 3? The answer is 3. Okay, that's the answer for question number 2. 3 availability zones. In our case, 1 data center per availability zone. They are physically separated from each other. They're in different locations. We'll get into those details in a minute. Okay, for chocolate, why? Why build 3? Why not just build 1 Uber data center in a really tall building and chuck everything in it? I mean, it'd be way easier, a lot cheaper. David, what was that?
Redundancy.
Redundancy, very good. What else?
Security.
Maybe security, yeah, that's not a bad. Anyone else got an answer?
Reliability.
Well, I heard reliability.
Reliability.
Very good. Reliability, you said?
Same thing.
Same thing, awesome. What else? Let's get a little bit more scientific. SLA, thank you so much. Exactly. So SLA, that's not the only reason. All of your answers are correct. If we really boil down to why we're building 3, though, you think about it, Microsoft are financially backing or guaranteeing, we are financially guaranteeing that these services are going to be available to a certain SLA. And you can't have a 4.9 or a 5.9 SLA like we do with Cosmos DB if you're just serving out of 1 data center. Now, some vendors will tell you that they can, but we don't. We like to not trick you into buying our products. We like to be very clear about what we're doing and how we do it. And that's why we go to all of this huge expense and effort for building 3 disparate data centers. So I'm going to give the chocolate to my friends here. Richard. That's right. Well done. Cheers. Enjoy that. 3 things I want you to take away with you today. Okay. We're going to go into these in a bit more detail. The first one is Azure is coming and we need to be ready. Our phone's going to start ringing. Our stakeholders are going to start asking us about these things. We need to get prepared. Number 2 is we need to embrace availability zones for those great reasons you just called out: security, reliability, to maintain an SLA. That's going to also impact the solutions that we work on. And number 3, we need to talk about is the DR region of choice. So you had an excellent question earlier about, okay, how's region peering going to work in New Zealand North? We need to understand a little bit about that. If you don't know what the region pair or what we're talking about there, don't worry, it's good news. We get more choices in terms of our replication target when we want to replicate data. So we're going to get into all of that right now. But first of all, this is a message to architects and engineers and strategists and technologists in the room. We're seeing Azure global expansion like we haven't seen before globally. This is not a Microsoft fact. This is something I read in the news. Microsoft is spending $1 billion per month on global infrastructure. Now, put that into context, the Waterview Tunnel in Auckland took 10 years to build and cost $1 billion US. And that's what Microsoft is spending every month. And that's not just Microsoft. All the big players are doing this. So we're talking about phenomenal investment. And guess what? This is arriving in our backyard. We had 50 to 100 data centers planned to be built in 10 new countries last year alone. And one of them is right down here on the very, very bottom right-hand annoying corner of the map, which is us, right? New Zealand North. It's there, and it's coming very, very soon. In fact, Jimmy was gracious enough to share with us a pretty good date for next year. It's mid-calendar year 2023. That's next year. That's like not even a year away. That is really going to come up fast. So we need to get ready and start learning about how this is going to work, because I would describe what's happening now as the calm before the storm. We're talking about data center infrastructure that we haven't seen in this country before. We're talking about expansion that never stops. You have a look at this slide. I'd love to say this is live footage of New Zealand North. It's not. It's a data center, or it's a region, sorry, somewhere else. I think it's either Europe or the States. I'm not too sure. I honestly don't know. But have a look at that red circle, and I'll zoom into that. That is another phase. That's not phase 2. It's probably like phase 5 or 6 of this particular region. We never stop building. We've announced 3 data centers. There could be 4. There could be 5. We never know. We probably won't know. We don't usually announce those unless we're making a really big announcement like a new region. It is global infrastructure at an industrial scale. You might have noticed that there was a megawatt number on Jimmy's slide. I won't repeat it. We don't really like talking about megawatts because it doesn't really matter. But to give you an idea, one data center that we're building, and we're building 3, one of those is bigger than anyone that has ever been built in New Zealand before. That's a big deal. And why that's really a big deal is because this creates opportunities for us, for our company, for our companies, for our customers, and for us individually. When you look at these hallways now, there are a couple of people in this room who actually are going to be working in these hallways. And if you hunt around and find them, you get to talk to them. They are super excited about this as well. But this is, if you've been a New Zealand data center operator one, I've been involved in this. We're talking about highly automated, very compliant environments. There's not people rocking around with network cables and meters and stuff like that, or ripping out hard drives and trying another one. Any of that. This is very, very clean. Very tidy environments. I've been lucky enough to be through one. If you get the opportunity to do an executive briefing center tour, jump at it. Just fly to Seattle and do it. It's absolutely incredible. And you can go and see these. You've got to jump through several hoops to be able to get access to a hallway, but you can actually do it. And everything is controlled, right? You can't just rock up to a rack and go, I'm going to start playing with this. You have to go through access, apply for that. Very extremely secure environments. Now, why am I telling you all of this? It's because we need to start thinking bigger. From a New Zealand perspective, this is going to open up projects that haven't really been considered before in New Zealand, projects that possibly were put onto the back burner for a few years from New Zealand, from our customers, our stakeholders, our boards are going to start asking questions about how does all this stuff work? What is this cloud thing, and how is it going to work in New Zealand, all of this? And I see this not only as an opportunity for your organisations, and not only an opportunity for the country. Shireen talked about, there's a dividend to having these data centre investments in New Zealand. That's absolutely right. This is impactful on communities and people, but it's also impactful on us. Okay, this is a career-defining moment for some. This certainly was for me. When I started learning about how these data centres worked, it's taken me on a whole new journey that I never thought I would be on. I'm a boy from Whakatane. I never thought I would be working inside a data centre or, working on projects like this. So super cool. And we get this opportunity now to skill up and to learn about how do these new hyperscale data centres work. How do we architect for them so that we can run workloads in these data centres and really exploit them? So exploit this opportunity to be the best for our customers. So a couple of things I'll leave you with in terms of how can you get ready. The first one is the well-architected framework. So on Fast Track, we do a lot of architectural reviews. So we may have customers ask us to come and validate their architecture. And when we do that, we use a framework, and that framework is the well-architected framework, which is on the Azure Architecture Centre. Luke talked about it earlier. It's a fantastic resource. I use it every day. We are walking in, and this is something you should have in your back pocket. You should be able to pull out of your back pocket and say, okay, let's evaluate this architecture along the 5 pillars of the well-architected framework, which are brown egg chocolate. I'll just tell you what it is. It's cost optimization, security, performance, operational excellence, and reliability. Okay, you should have that memorized. You should not just written on your hand like I do. You should actually, study that and get to know that so you can talk to customers about how to architect for that. The next one is Microsoft Trust Centre. Microsoft Trust Centre is where you will find compliance information, white papers on enabling data residency and data protection in Azure, which is really good for New Zealand customers, because don't forget, we have some customers in New Zealand who are concerned about data residency and we need to answer those questions clearly. This white paper has the answer to those questions. It's very, very good. And the final one is a shout out for Microsoft Learn. So Microsoft Learn today really is my preferred resource for training and upskilling and keeping up to date. Personally, I prefer it to the exam process. I love self-study and I love learning at my own pace. And Microsoft Learn, the quality of the content is very, very good. And it allows you to keep on learning and keep on upskilling about important stuff, including Azure architecture. So those are 3. So that's all about getting ready. Okay, so just a little pep talk about this. This is coming a lot quicker than you think. And we're going to get really busy the closer we get to the launch date of New Zealand North. The second thing I want to talk to you about is availability zones, specifically high availability. And I'm talking about high availability first before I talk about disaster recovery. So we're going to sort of tear those conversations apart, right? My pen stopped working. First of all, let's look at the physical architecture of an availability zone. Jimmy talked about this. We're going to drill in just one level deeper now and talk about what is the physical architecture of 3 availability zones in the New Zealand North region. Well, we have independent power, cooling, and network for every single availability zone. They are physically separated by a meaningful distance, in our case, kilometres. Okay, you actually saw a map of rough locations, and if you know the geography of Auckland, you see they are actually considerably far apart, which is great. The network round trip we aim for is less than 2 milliseconds. For New Zealand North, it's going to be much less than that. That's close enough, that's a low enough latency for us to be able to do synchronous replication and synchronous calls between those availability zones, which is what's going to help us when we get to the logical architecture of these centres. And we have diverse fibre paths. So you heard Jimmy talking about upgrading the fibre links that we require. We don't just rely on one connection or someone else's connection. This is Microsoft fibre. This is dark fibre. We have one of the largest private wide area networks on the planet, and that's fibre that we might be laying conduit for, that we might be building cabinets for, to actually enable these networks to bear the capacity that we require. So that's a significant amount of physical infrastructure and architecture, right? And that's a big investment. Why? Why would we do that? Well, as we said earlier, it's because we want resilience and reliability. And when we look at the logical architecture now, so let's go up a level and look at how this looks logically from a solution architect's point of view. We have platform services that are deployed across zones for zone redundancy. So I work for Azure. Azure is all about platform services that you can build other services on. And what we want to do, you think about a platform service in Azure like Service Bus, Azure Cosmos DB, Azure SQL DB, et cetera, et cetera. These are services that are striped across hundreds of VMs, sometimes up to 1,000. And what we're doing is we're striping that cluster of VMs across all 3 availability zones. And we can do that because they're close enough to each other to do synchronous replication and synchronous calls. So when you stripe a cluster that's serving an individual client through a zone redundant load balancer, now you've got incoming calls coming into your zone redundant load balancer that are being served to the nearest or to an available node, and that allows us to do a few things. One is we can rotate nodes. If a node's unhealthy, we can flip it. It's okay. There's another 100 or so there waiting to take that load, so we can continuously upgrade, patch, and release onto those nodes. That's how we maintain an availability that's higher than 3 nodes. The other thing we can do is if one of these nodes one of these availability zones was to become unavailable, then we've still got a quorum. Still got 2 nodes that are going to pick up that traffic and continue to function. And when we're getting up to 4 or 5 9 SLA, that's absolutely essential, right? And the third thing is that our Azure Management Services, known as ARM, so what you just saw, the great demonstration from Luke about the Azure Resource Mover, that runs on top of our Azure Management Service, which is called ARM. We also replicate that across 3 zones. And that allows us to keep on managing the platform, managing Azure when we have a zone failure or there's any issues in that or we need to upgrade those nodes, et cetera, et cetera. So that's for platform services. For VMs, so if you're deploying VMs, as Luke pointed out, you can deploy VMs zonally. It means you can pin them to a zone. You say, okay, this one's going into zone 1, this one's going into zone 2, and build HA architectures like that as well. I'm a PaaS guy, so I'm going to say that zone redundancy, I think, is more reliable, and you're better off really if you can use a platform service and zone redundant configuration, generally speaking, than zonal. Zonal's great, but you've got to manage it. Someone's got to be available to make those decisions about where those VMs are deployed and which one to rotate and that sort of thing as well. Cool. So where does all this sit in terms of HA? So let's get back to first principles in terms of discussions with our customers internally about high availability. The first question that I like to ask is, what is your recovery time objective or your RTO? It's how quickly do we need to get back online if something is to become unavailable, right? This question is usually answered either in seconds or minutes or hours. Seldom days. Days would be way too long in cloud. It's relatively easy for us to provide an RTO that's measured in hours in cloud. Minutes and seconds gets a bit trickier, but we can definitely design for that. But that's generally question number 1. The second question is, what is your uptime service level objective or SLO? And some customers or solutions may write these up as SLAs, which is a service level agreement, but really it's an objective, right? Our objective is to get to this level of uptime. It's a really good way of looking at it. I pinched this from Uptime Is, which is a fantastic website for reasoning about uptime. But you look at the difference between 2 nines, which is when we're planning for, not expecting, planning for 7 hours plus of downtime per month. That's enough time to do a maintenance window, to patch some servers, to take them down, do a Sunday night release, those types of things. You contrast that with 4 nines or 5 nines. We've now got just a few minutes or a few seconds available to us to go and update systems before we start breaching SLA. All right, so the whole game changes when you get up to this end of the availability spectrum. Now we're talking about clustering, we have to, and we're starting to talk about physical redundancy as well as logical redundancy. So it's a really good way to think about uptime with your customers. How does this fit into architecture? So unfortunately, we've only got half an hour today, so I don't have time to go in depth into architecture with your reference architecture, but we're working on these and we're going to publish many of these reference architectures shortly, and we will so that we can share them with you. But here's a typical, very high level, quite naive really, single region architecture which embraces zone redundancy and availability zones. And essentially what we've done is every one of these platform services that's on this architecture can be enabled for zone redundancy. So if you're in the portal, you're ticking the zone redundancy box. If you don't use the portal, use Bicep and set the property to do that. And we've got app services, function apps, service bus, Cosmos, you name it. They're all zone redundant services. Remember, They're running on very large clusters that are striped across those 3 availability zones, and that gives us a very high level of availability. The composite SLO on a design like this can be up to 4 nines. That's very good for a single region. We can achieve higher than that if you want to, but we need to talk. We need to show you how to do that. That's availability. Now I'm going to move on to disaster recovery. I'm separating these discussions because it's the right thing to do. Under the reliability pillar in the well-architected framework, we talk about resilience, and then underneath that, we talk about availability and recovery. Okay? Now, they are absolutely connected, and it's important, but they really are separate discussions in terms of how we plan for them. So let's talk about DR when you've got New Zealand North, which doesn't have a region peer. So first of all, let's go back to first principles. We've talked about RTO, so recovery time objective is definitely important for disaster recovery. But we also need to talk about the recovery point objective. The recovery point objective, the awkward way of asking that question is, how much data are you prepared to lose in the event of a disaster? To be able to answer that question, you have to be able to define what is a disaster. That's actually really hard, because everyone has their own definition or their own mental picture of what a disaster is. For the purposes of this discussion, I'm going to say that a disaster is a failure of any kind where we are unable to recover the data. I'd add a bit more to that actually, but just for today, we'll keep it simple, and we'll say that it is a failure where we are unable to recover the data. The answer to this question is usually measured in seconds or minutes or hours or possibly days. So to give you an example, if you're running a SQL server and you do full daily backups and you're shipping those backups to an offsite, and you've got an RPO of 24 hours or 1 day, right? If you're doing incremental hourly backups, now you're shipping them offsite, now you've got an RPO of 1 hour. So that's a good way to think of it. Once we understand our RPO and we thought about that, then the next logical question is, where will you store the backups? So this goes back to tapes, right? When we used to store backups in tapes. Where do we keep the backups? The answer is not in the glove box of your car. It should be, offsite at a location. We don't store backup tapes anymore, so just pretend I never said that. But where do we actually put the backups? And this is part of our DR design for this. So there's a few options in Azure. Up until recently, I would say it was region pairs. So region pairs, an awesome feature in Azure where you literally tick a box in your storage account called GRS, Geo Redundant Storage, and that will synchronize your data between 2 regions. So Australia East usually would be the primary. Australia East is paired. It does have a region pair. It's Australia Southeast. Australia Southeast would be the DR region for Australia East, and we would use GRS, which is an asynchronous replication mechanism, essentially, to copy data from Australia East to Australia Southeast, and that's our offsite backup. Okay, that worked brilliantly. There's a couple of big problems with that. One is we don't get to choose the region. It's Australia Southeast, or sorry, that's it. That's the only option. The other thing is that when you're in New Zealand North won't have a region pair. Okay, so there will be no GRS in New Zealand North. And that can be a shock to some customers because they're used to just ticking that box and having that offsite backup. So the good news is we have new technologies that are actually better than GRS in my opinion, which are called object replication. This is a storage feature, easy copy, and also data replication of services. So I'm going to show you how that works. So think of this, I guess, as just between us and the thousands of viewers online. I think Microsoft are really starting to move away from this paired region concept to object and choosing your own DR region. So we can either so we've got a few options. We could DR to the same region. So let's just think about that. Before we think about another region, we're in New Zealand North. This is New Zealand North. Remember the physical infrastructure, massive physical infrastructure, 3 data centres separated by meaningful distances, which all have their own power and cooling in there. If we turn on zone redundant storage, we are now striking 3 copies of our data in each data centre. So there's 3 copies there, 3 copies there, 3 copies there. The durability on ZRS storage is 12 nines. That's 2 nines and a decimal point, and then another 10 nines after that. If you subtract that number from 100, you get the probability of losing that data in 1 year, and that number is very, very close to 0. Okay, so you can say to your customers and reason with them and say, you know what, I think we're good. I think we've got enough durability inside this region. We're going to store our data striped across 3 availability zones. We've got excellent durability and all of that. And they're going to say, you know what, Dan, I love that idea. I get it. I understand the science and the engineering behind it. But you know what? We're the customer and we set the business requirements. We should always go to the customer and ask them the business requirements, right? It shouldn't really be architects and engineers making this stuff up. And they might just say, you know what, that's all great. I really just want to store it in another region. I want an off-region backup or a cross-region backup. Okay, so I just want to reiterate though that for 99 out of 100 cases, this is good. You're good. You know, you can sleep at night. Your data is going to be safe. If for any reason you want to mitigate the risk, or your customer says we want to store it in another region, then now we have a DR region of choice. So we used to say, okay, you're in Australia East, your DR region is Australia Southeast. But what if I want a DR to US West? Or I want a DR to UK West because I've got another operation over there. We have lots of customers in New Zealand that have operations in the UK and no bounce in between. So what if we want to do that? We can do that, or we can choose really what is probably the most logical DR region of choice for New Zealand North. And that would be Australia East, right? It's a hero region. It's got 3 availability zones. We're now getting to our so-called 3+3 architecture. The durability of that, I just can't even do the maths on that. It's such a massive number that's so close to zero. The probability is so close to zero, it's not even funny. I think that this is probably going to be the DR region of choice for customers who want a cross-region backup for their backup data in New Zealand. In fact, I think this is such a good idea that Jimmy and I and some others, we got together. Jimmy's putting through the paperwork, and we're actually going to rename the Australia East region. We're going to call it New Zealand West. I think that's just going to make things way easier for everyone. Everyone's going to be a lot more happy with that. And it kind of just, it's a good way of thinking about our DR region of choice for New Zealand North. Cool. So how do we actually do it? So zone redundancy, remember this single region architecture, the zone redundancy. We had these zone redundant services deployed in a single region. Now we're going to add replication. So we still get the availability and durability of a single region, but if we want to, we can now back up our data to a secondary region. So that's the primary region on the right, that's New Zealand North. This is the secondary region, that's New Zealand West, formerly known as Australia East. And this is where we're replicating our data using a couple of technologies here. So if you look closely at this diagram, and apologies, I can't zoom it in, but this green arrow here is going from the ZRS storage account to another storage account replica using object replication. This is the new technology that allows you to choose your DR region. SQL database read replica we can do, so that means we can have a hot read replica, which is asynchronously replicating into Australia East, and that's on a line ready to take off the load if we want to. We can also actually take full backups from that replica, but that's a slightly longer and more complicated story. But if you want to hear a really cool story, Cosmos DB allows you to stand up a read replica in Australia East, so your primary is New Zealand North, your secondary read-only replica for Cosmos DB is Australia East. Plus, we can take a continuous backup from that replica into a storage account that allows point-of-time restore to any point of time. That's amazing. So that really can give you durability of data and disaster recovery options that we could only really dream of prior to having this type of technology. And as we've just said, all of this technology now is arriving in our back door. So it's pretty cool. So that's it. That's my talk, half an hour. Unfortunately, I haven't had a chance to go into more detail on the architecture. I'd love to do another talk one day where we explain the architecture in a bit more detail, but we're done for today. So I just want to remind you of those 3 things. The first one is Azure is coming. We need to be ready for this industry-defining event. As more and more people get aware of the potential of these regions and how they can be used, they're going to start calling you because you are the experts. Okay? And they're going to be asking questions about how do we design for these regions, how do we plan for it, and how do we get ready. I've already heard from Jimmy in terms of we want to know your plans, so please let us know how we can serve you when these regions go online. The second thing is embrace availability zones. This is the way forward. Fast Track have been talking about availability zones for years now, since Australia East availability zones went GA. This really is how we should be architecting for designs now. We used to talk about multi-region. We do have a few customers who need multi-region, mostly first-party customers of Microsoft. Think about Xbox, Teams. We've already seen Office 365 and M365. They might need a hot architecture across multiple regions, but they've got tens of millions of users to 100 million of users. It's another order of magnitude. For most customers, multi-zone designs are better, they're cost-effective, and they offer an extraordinary level of availability. And the last point is, remember that DR region of choice. You're no longer pinned to a secondary region. You can choose your region, and you can set rules around that. The policies are incredibly dynamic and give you a lot of power in terms of choosing where that data is going to be replicated. And it does mean a shift, though, in terms of how we've done things in the past. So you may need to just sit down with customers and explain what's changed and why we're doing it. That's it. Thank you so much, everyone, for listening. We really appreciate your time today. That QR code, if you hold up your camera and take a picture of it, will take you to my GitHub repo, which has got a copy of these slides, which are already uploaded, and we'll also put up other resources for that as well. So kia ora, nō reira, tēnā koutou katoa.